Okay, so this is the second interview on this channel. I'm here with my friend Nicole Kitt, who's at the University of Waterloo. Uh, you're in your PhD now?
Yeah, I just
Yeah.
started my first year in September. Yeah.
Right. Yeah, doing her PhD at the University of Waterloo. Like my first guest, we actually first met at the Alberta Algebra Summer School. And Nicole was also at the summer school in Toronto on mirror symmetry. So hi. Yeah, I guess to start things off, you maybe want to tell people what your current research interests are, things you're currently looking at.
Sure. So I'm not doing a whole lot of research right now because I'm just starting. So it's
Right.
lots of coursework. But I guess like my research area is like best described as probably like representation theory, but via like algebraic geometry and stuff. And so, which just means that you're trying to solve a rep theory problem, but you use tools from like algebraic geometry and like maybe other areas like geometric invariant theory and stuff. Yeah, so I guess like my project is kind of, we're looking at like a class of like Lie groups, which is just like a group with a manifold structure, and it's in a compatible way. And we're trying to basically classify certain representations of certain Lie groups kind of vaguely. That's like the most vague way I can put it. But right now I'm just doing lots of background reading and stuff. So don't know a whole lot yet, but it's fun. It's interesting stuff.
Yeah, so you mentioned right before I started recording, you mentioned you were taking a class in geometric invariant theory. Do you want to just like briefly describe what's involved in that?
Sure. So yeah, so I guess like, I mean, we just started, we're like in week 4. So we just kind of got to the meat of it. But basically the idea is you have like a group. Usually you can take it to be like it can be like an algebraic group. So it could be like reductive or just like a Lie group. And then you have say a variety. For us, we're just going to be like affine varieties. And so you consider like a group action. So this group's going to act on this variety. And so this is kind of where like representations come in. But anyways, and so through this group action, you kind of get this quotient space, right? Which is like this set is just going to be equal to like all the orbits from this group action, right? And so like this has a natural like topology, the quotient topology. And so like I guess the first question of geometric invariant theory that we usually ask is like, so we have a group acting on a variety. Does this quotient admit like the structure of a variety in like a compatible way with the quotient, the one from the equivalence relation?
Right.
And so that's basically like the idea. And so then that's where this thing called the GIT quotient comes in. And so it's basically like a generalization of that. And in some cases, it has a nice variety structure and such. Usually, I think it's when, I think we haven't proven it yet, but when your group is like reductive. That's all I know so far, but it's neat. Yeah.
It sounds like that might almost get into stacky kind of stuff, right? You're taking quotients of some variety structure and you're hoping it has some variety-like structure. Is that relevant at all, or?
I don't know. I vaguely know what a stack is and not nearly enough to answer that question, but probably. I feel like somehow related, like most things, but yeah.
Yeah, I mean, I don't know tons about stack. I know about enough about stacks to like think that maybe that question isn't totally insane to ask. So
no, it's probably
yeah. So yeah, let's take things back a bit and let's talk about how you first got into mathematics. Like, were you into it at a fairly young age, or are there any like memorable experiences or people that made you realize like, oh, math is a thing I want to spend my time doing?
So I guess, yeah, definitely didn't always like math. I kind of didn't do super well in it in like junior high and high school. I definitely did have like a defining moment. I think my grade 11 math teacher, he kind of changed the way I thought about math. I definitely didn't like it very much before I took math with him, but yeah, he was just very, I think, enthusiastic and cared about his students a lot, and that makes a big difference, I think. But yeah, he spent, I guess, one class, he talked about like the Fibonacci sequence. He spent like a whole hour talking about it with us, and like I've never seen anything like that before, really. Like usually math before that was just you multiply big numbers, or you like I don't know, find out the cost of like 1,000 watermelons or whatever not.
Right.
So then yeah, and then I took pre-calc with him. It was hard, but it was a lot of fun. And then yeah, I don't know. I didn't really know. Even then, I didn't really know I wanted to do math. I wanted to be like a dietitian. I like to run a lot, so I'm like into sports. I always played sports, so I kind of wanted to do like be a dietitian. So I went to university for like general science. Didn't really know what I wanted to do.
I didn't realize that you started off in general science. Yeah, I guess I assumed you just started as a math bachelor.
No, definitely not.
Okay. Okay.
I took lots of math. I took like algebra and like all the calcs, which was hard, but it was cool. It was, had no idea what was going on, but yeah. And then I ended up engineering. That's when I transferred to University of Calgary. But I applied. I just like applied for engineering and pure math. But I remember like looking at the application form and like having to decide if I needed to like apply for like pure math or like applied math. And I remember like reading the descriptions, and I like had no idea what difference between them was. So I just was like, oh, I'll just pick pure math. Yeah. But I don't know, I guess like a year my degree of engineering and pure math. I didn't really take much pure math courses at that time because the engineering schedule is pretty hefty, but I was in a course called Foundations, which I definitely did not have the prereqs for, but it was cool. That's like where you construct like the natural numbers and like the real numbers, like Dedekind cuts and all that spooky stuff.
Right.
And I took Algebra 1, and I think the course is really kind of, one day I just woke up and decided that I wanted to do math and dropped engineering and stuff. So I don't know. That's, I guess, basically the long-winded story, but yeah.
So you mentioned that you transferred to the University of Calgary. So you didn't, where were you going before when you were thinking about being a dietitian?
Oh, I went to Grant MacEwan University. It's in Edmonton. So
okay.
I did my, so that's just a university in Edmonton there, a smaller one. Yeah.
Right.
Yeah, so 2 years there and then transferred. Yeah.
Right. So then you ended up doing your undergrad at the University of Calgary. And that's when you started doing, so I remember you telling me about some of the stuff you had been working on there, was sort of got into more algebraic geometry type stuff. So yeah, how did you come to get interested in the subjects you're interested in now versus like other subjects, / like what brought you to Waterloo specifically?
Sure. Yeah, I think I just really like algebra. It just makes sense. I struggle with analysis a lot. It's cool, but I don't know why. It's kind of a hard question to answer, but I think I just had I took like Algebra 1, and my TA was like exceptionally well. He was very great. He was very enthusiastic and talked to us for like hours after class. And I'm good friends with him now, actually, still. So he kind of I had him kind of along with me the whole way, which is kind of nice. He's a good mentor. But yeah, I don't know. I remember taking Galois theory with a professor who I did research with, that project with. Yeah, I don't know. He was just very enthusiastic about math, very excited, and he made math just like really fun. And I just asked him, do you want to do, I was like, well, I asked him if he'd teach algebraic geometry the following year without knowing what algebraic geometry was. But I thought maybe it would be something that would be fun.
Right.
Which it is. Turned out that I liked it. I just got into research with him, and he kind of just gave us a problem to work on that he had related to kind of his big research group. It's kind of related to that, but yeah, it's basically it was a rep theory problem that we solved using like algebraic geometry and linear algebra. So it was fun. It was hard, but I learned a lot. But it was a good experience. I got to collaborate with all of his collaborators, and so I got lots of connections and got to meet lots of cool people, so it was fun. And then what brought me to Waterloo, I'm not sure. I think I decided I wanted to, after I did research with my supervisor in undergrad, I knew I wanted to go the grad student professor instructor route for math. And I knew I wanted to stay in Canada for my master's at least. So I applied just everywhere, I guess. UBC, Toronto, Waterloo, etc.
Yeah.
Yeah, I don't know. I think I was between UT and Waterloo. Both are amazing schools. So I just had to kind of pick at some point. But I went to visit Waterloo a few times, and I think first, I guess the pure math department there in Waterloo is awesome. We're very it's like a family, kind of like my undergrad. We're very close knit, and all the graduate students here are great. We all hang out, and pre-COVID at least.
Yeah.
So it's just very it's very welcoming, and I don't know. I feel like that's important. At least for me, it's important to be surrounded in a community with lots of support and stuff. But yeah, I guess it was just my supervisor here, Matt Cetriano. I know he's awesome. I guess that was the defining thing that kind of, I guess, decided that maybe choose Waterloo. Yeah, he's just very enthusiastic, like lots of professors, I guess. But he does cool math. I think he does very lots of more algebraic geometry side of stuff, but he knows a lot, so he can go in lots of directions, I think. And so, yeah, he gave me this rep theory problem to do, which I'm excited to work on with him. So, yeah, I don't know if that answers your question, but
no, that's great. And actually, in the last interview, that's exactly one of the things we were discussing about, thinking about grad schools as community as a really important aspect of that. And yeah, for myself as well, I really, I think, so I applied to PhDs this fall, and I think that will be a deciding factor. I know I've heard people say before you should, sometimes contact past graduate students and ask people about such and such supervisor when you're making that choice. But I think one thing I'm going to try and do is research more into what the general community is like at certain places. Do people interact? I mean, yeah, again, obviously right now because of COVID, that's going to be hard, but I'm hopeful that not my entire PhD will be on a computer. So
yeah, I know. I hope so too. Yeah. No, yeah, I think talking to graduate students is one of the best ways to gauge kind of what your experience would look like if you went to that university. But
yeah.
All
right. So why don't we get into the thick of it a bit, and why don't you break down a concept for us, something that's been on your minds lately? I don't know, it could be a nice, a simple theorem you like that you've been in a course you're TAing, or I don't know, some fancy concept from the courses you're taking right
I mean, yeah, I guess my brain is focused on coursework right now. I mean, let's see, I guess. Well, I'm actually wrapping up. So the undergrad project that I did, however many years ago, that was 2 years ago, we're finally kind of wrapping it up and typing things up together. I've been thinking about lots like that a lot. What else? I don't. Let's see. Yeah, I guess like maybe I'll talk a bit about maybe that because that's what I've been actually thinking about. Let's see. So like basically the idea is that we have like this giant like variety, which I mean, so think of that, it's just going to be like it's a solutions to a system of equations, but we have like over 100 equations and like something like 117 variables. And so like computationally wise, it's a very difficult problem to like work with this variety. And so it basically essentially it has like a singularity in it, which we're trying to like locate, right?
So are you using like any like computer algebra system then to help with that? Because that sounds like obnoxiously huge, like something you'd want to use Sage for or something.
Yeah, we're using, it's called Macaulay 2. It's like I don't know, I think it's like a mathematical like algebraic geometry like computer type. I don't know what's the proper word, like language. I don't think it's like a language. I'd probably get in trouble if I said that, but like yeah, we're using Macaulay 2 code in there. Because yeah, it's computation. Like we do some of the calculations by hand, but it's like it's fine. But it's like when we have like a giant like Jacobian matrix, it's like huge. You can't like look at it and start like, you know, working with it by hand, right? So we do lots of the computation. Yeah, right now we're actually trying to do this like Hessian calculation, right? So that's like the matrix where you take like all the partial derivatives, right? And we're trying to do that with, like a particular function that we're looking at, but it has all these relations that kind of describe it that we need to like shove into this one function, and it's very hard to do. So that's what we're trying to do right now, I guess. But with this like Macaulay 2 thing, so it's cool. It's cool because it's like a very like pure math problem, but we're just computing things on the computer, so it's kind of cool.
So yeah, so you mentioned so you started writing things up about this, and I guess there'll be a paper coming out of it at some points, or
yeah, we're hoping to get that done shortly, you know, like how you start writing things and then things pop up, so that's kind of the stage, but the horizon is within sight, so yeah,
that's
within
good.
the next yeah, that's why we're doing this last minute computation, trying to figure it out, but yeah,
so it's quite a long journey for this paper.
Yeah, I started it like this project like 4 years ago or something. It's just, yeah, but we put it away like I did my master's last year at Waterloo, right? So it kind of was out of the picture for a year, so yeah,
but
get that done.
I think that's really good that, you know, because lots of times people will do an undergrad research project for a summer, and well, you know, if you're lucky and you know you're able to prove some result and get most of a paper done, then you know maybe your supervisor polishes up the rest and it gets published, great. But I think a lot of times, I could be wrong, this is my perception, a lot of times well, if you don't get a result, then that's just the end of it. And I mean, it's still great, it's a learning experience, you get a taste of research, you learn some stuff, but it's my impression that typically ends there. So the fact that, you know, you've stayed in touch and have continued this thread and continued to work on that project, I think is pretty cool.
Yeah, Yeah, no, I would agree with that. It is hard. Undergrad research is hard. You kind of, it could be anything, and but I guess, yeah, you do learn a lot though, and it's a very good experience. But I think I was like, yeah, I'm definitely fortunate to like kind of have the opportunity to let this kind of like sit and like boil in my brain for years, because like taking it when I first started, like I had to black box so many things. Like I
Right.
had no idea.
Right.
The first year, yeah, I don't know what's happened, but like now I've taken like a bunch of courses at Waterloo where like I learn what like these objects are, and like
Right.
concepts, like, things like a even like a GIT quotient. Oh, it's in our paper now. I saw that today, so like, oh, I know what that is. So
Right.
like definitely, I think that's like an advantage of, I guess, keeping a project for that long, is you kind of understand it a lot. I understand it a lot better now than when I definitely like 2 years ago. So
Right. How detailed of notes have you kept throughout? Because I've so I'm coming up, I'm starting to, work towards a final good copy of my thesis. And like on one hand, I have been taking notes the whole time, so it's not like I'm starting at page 0 and writing everything up. I already had a lot of material there to work around in. But there's also been certain places where like I thought I, took some good notes, and then I went back, months later, I'm trying to, refigure out this part of like the code or some lemma that I proved. And I'm like, what was I talking about here? And it's really made me go, think about, as I progress forward, to really be more conscious of taking detailed notes as I go along, to make it that process easier of piecing it together. So have you, like, what's been your experience with note taking? Have you had a similar experience where you went back and it was like almost a foreign language, or were you like, oh, thank God I made a detailed proof of this lemma and I understand what I'm doing?
I think it's a little bit of both. I think I really, I guess I really like teching, so I like to just like, so I definitely do like make very detailed notes, I think, of like everything. That's what I did, at least in my undergrad. I like every single detail, lots of which were wrong at the time, but recorded like everything. And that was definitely helpful, especially like coming back after like you've been away from the problem for so long. It's helps you bring yourself up to speed.
Right.
But definitely have moments where I'm like, what? Like, yeah. So I think it's hard to like really get everything, but try my best. But
Yeah.
I think everyone has their own. I got an iPad which has been like exceptionally helpful, especially during the pandemic. So I do like my scratch work on there, and then like anything that's like really important, I just like type up immediately. I'm trying to get into that habit, but yeah.
Yeah, good habit to have. I've been meaning to take more notes of, I've been sitting in on some courses, or once in a while I'll see like a little problem that'll pop up on like Facebook in some math group, and I spend a couple minutes scribbling at it, and sometimes it leads to something interesting, but it becomes a thing that sits on my whiteboard for a while and then eventually gets erased. And I'm thinking maybe it'd be an idea to keep more of like a math diary, and just have like a tech document on my desk I can just open up and quickly like, here's a thing I thought about today, or prove a little lemma, something. I guess that's what blogs are for. People who have math.
True, yeah. Formal, yeah. No, I think that's a good idea. I had a professor tell me that once. He said, once you get to graduate school, get a little notebook or a tech file, wherever you want. And any idea that like pops into your head, just write it down, even if you think it's silly at the time, because like years later, you might be looking through it and you might find like a good idea, or if you're looking for a problem or a project to work on, right? You have a book of things. Yeah, I guess it's good practice, just like writing your ideas down on paper and trying to like, I guess like I think like one of the hardest parts is like just trying to come up with good problems. So maybe that would maybe help, develop some of those. you know.
Right. Yeah, the art of coming up with problems.
Yeah.
So you mentioned, I guess you kind of answered one of the questions I have already. Is you know, what if you weren't doing mathematics? What would you be doing instead? But I guess it sounds like you'd probably be a dietitian. Or has your stance on that changed? Like, what do you think now if someone came and was like, yeah, you're not allowed to do mathematics anymore for whatever reason? What do you think you'd be doing instead these days?
Yeah, no, I actually think about this a lot. Do I want to do that? I mean, I do want to, but it's a hard route to do. Like,
right.
I definitely want to do my PhD. You know, whether you get a job after is kind of
right.
It's a hard, you know, field. So, I've been. I don't know. It's a good question. I mean, let's see. I think if I were like, if I couldn't do math and I can like start over, I think I'd want to do like something more like into like physics. But maybe I really like, I don't know. I like black holes, and like wormholes are really cool.
Oh yeah.
It's kind of like a hobby. I watched a lot of Netflix documentaries this summer, let's say. So that's like the extent of my knowledge, but I think it's cool. And like space and stuff. I don't think I'd want to do like quantum or like stuff like that or anything. I just like space is cool, but I don't obviously. And I don't actually know what that comprises of. Like, if you want to like study like black holes, like I have no idea what that means or like what you'd even do. But I think it'd be cool to like do something like that. Yeah.
So you think would you be more on like the theoretical side of things, I guess?
Yeah, I think so, definitely. I mean, I don't know. Yeah, I think so. I don't think I know enough to like answer that question, but yeah, I don't know. I think it's cool. That's like my reasoning. What else? Yeah, I don't know. I think there's lots of things that I would enjoy doing. Like, I don't know, working in a coffee shop would be fun, or like owning a coffee shop. I really like animals, so I think it would be fun to do something with like maybe like nature conservation or something. That also has like a math aspect, so you never know if I ever go into like industry or something.
Right.
Options there, so yeah. But yeah, I like math. So
yeah, I think something I just vaguely remember reading some article a while ago that was talking about some interesting, I guess it was more on the stat side of things, but they were talking about applications of mathematics to looking at forest dynamics and tree populations, and there are some interesting applications there. One thing, have you watched any of the PBS Spacetime videos?
no, I don't think so.
You should check it. So it's a YouTube channel called PBS Spacetime, and they have a whole bunch of physics videos, and so plenty of stuff on like black holes and general relativity. But I think you would really enjoy it because it's definitely, I think it really hits this nice stride between like there's a lot of it is accessible to lay people, but I think even someone who's doing physics could still watch the video and feel like they're not sitting in a kindergarten classroom, basically. So I think you in particular might get a good kick out of those videos, because yeah, they're at a nice sort of like in between level there. I might even, for people watching, if I remember, I'll put a link in the description to the channel. Yeah. The other thing I'd recommend, I mean, I know So like I have a million books and I never ever have time to read them. I just bought a couple more books that I don't have time to read. But if you are wanting to check out some stuff in your free time, I recommend this frickin' mammoth of a book, The Road to Reality by Roger Penrose.
Very nice.
It's so good. Like this is also a great, I think, in between. I mean, I think the goal of the book, quite lofty, is in about 1,000 pages, take a complete layperson who just knows like a squared plus b squared is c squared and tell them about string theory and its alternatives, which, but like with mathematical detail, like there's like here's a page, you've got like an actual like the differential operator of a Hamiltonian, and there's Lie group stuff involved in here, and all those crazy things. But it's also good for someone who's say in mathematics but interested in physics, because it's more interesting because there's actual mathematics equations for you to latch onto. Like there's Lie group and representation stuff that's like, oh, I can like read this language and it's got some substance. So I would also recommend checking out this book. I mean, there's plenty of quantum in it too, but like there is actual, like it'll tell you about black hole entropy, tensors, Riemannian geometry. It's all that crazy stuff.
Nice. No, I definitely will. Yeah, I've like kind of sometimes I'll like go in the archive and like a paper pops up and it's like it has some black holes, but it's like, yeah, there's also like differential geometry and stuff.
Yeah.
Which is cool because like I know a fair amount. But yeah, it's just like I think it'd be cool to like do, like I want to stay in math, but it'd be cool if I can do something that like goes somewhere in the more physicsy direction, maybe with like differential geometry and stuff. But it's just whether or not, I have no idea how to even get to there. But
right.
But yeah, that's cool. I'll definitely check out that book.
Yeah, and I think you can even, I think if you just like, never mind torrent sites or whatever, I'm pretty sure if you just Google Roger Penrose Road to Reality PDF, like it comes up, like the PDF comes up as one of the first results or something. But I would also recommend, like, I think I found this copy for super cheap, and I mean, it's great. There's like, always something to find in the pages of that book. I actually wish I'd like, because I'd known about this book a long time ago. I think I maybe even tried checking it out of like the Winnipeg Public Library, maybe at the end of high school or shortly after, and was like, obviously it was too much for me. Mm-hmm. Well, in many ways, there's lots of chapters that are super readable for someone who like, doesn't even know calculus or linear algebra. Well, from my perspective, I don't know, that's probably a little skewed about how readable it is. But, there's so many times that I've just opened that book up again for fun. Like, I'm sitting at home, I'm like, I feel like reading something else. I'll crack open that book to a random page, and there's some cool concept that it's like, maybe even a pure math concept. And I'm like, if only I'd stuck to this book a little closer years ago, like I would have known about this really cool thing a while ago, and it's, explained pretty well in here. So yeah.
Awesome.
Highly recommend. So yeah, do you have any advice for people getting interested in mathematics? Maybe, end of high school, maybe they're in their undergrad, wherever. Any particular lessons or insights you would pass on?
Let's see. I think like the biggest thing I would say is just like immersing yourself in like the community around you as best you can, like whether that be like trying to do undergrad research, or like going to professors' office hours, or talking to graduate students, or talking to your classmates and like working out problems together. I think that's like one of the biggest things I would say, because it opens up like a lot of opportunities, more than you'd probably imagine. But like once I started doing that, I definitely like, I started enjoying math like a lot more. It's a lot more fun to do math with others than by yourself, in my opinion, at least. But yeah, and like outreach is great to get involved in. But yeah, you make lots of connections that way, and you open up a lot of doors, I think, especially if you're thinking about going like the graduate route and stuff. That can be very helpful, I think, when it comes to like applying for schools and all that stuff. So
yeah, definitely. I mean, I think it's always, you know, been the case, and sometimes, you know, you hear the information and it just goes out the other ear, but like contacts are important, you know, like, yeah, you need a degree to do everything, but like, you know, what helps get you in certain doors is like knowing people and talking to people, and you know, and then one day someone like, oh, I have a friend of a friend, oh, he's looking for a graduate student that's interested in that, I'll send him an email to like set your application aside or whatever.
Yeah, exactly. Yeah, going to conferences, meeting lots of friends, you know.
Yeah,
like probably wouldn't have met you if I didn't go to all those conferences. Yeah, so yeah, it's good. It's fun to have a lot of friends everywhere. Because like whenever you go to a conference, it's like if you have someone in that city, you know, it's like, I don't know, it's fun. Yeah.
Yeah, that's the one thing I'm really bummed out this year is the Arizona conference in particular. I went. It's the Arizona Winter School. The last 2 years I've been, and I don't know. I like Arizona. Tucson in particular. I just like the city. I know it was a nice place to be. Yeah, I mean, great conference. I don't think I understood like a single lecture either time. But this year I was expecting to, because this year was more like things related to something I have half an idea about. And I was like, oh, I'll actually, you know, absorb some information and then.
Yeah, it's good to, I think, yeah, another thing I would say is like it is good to just like go to talks, even if it's like way over your head and you have no idea what's going on. Just like being there is, I think, even if you don't think you're getting anything out of it, you get a lot more than you think. And then I guess if you hear that talk again or something, the second time around, you'll probably have a lot more, you know, background and stuff, and you might understand it a lot better. But I'm bummed about the conferences and stuff. I've always wanted to go to that Arizona one, because you always brag about it every year, and like I'm always like busy, or like it's like I can't make it, but I was hoping to apply like this year or something, but clearly but or maybe are they doing like an online version? Like,
so yeah, what they're doing is there is an online one. I think the sign up has passed, although all the sign up means is just you have access to talking with people about specific problem sessions. So they're not doing the actual winter school, but they're doing I guess like more an introductory thing. So I think there's a course on modular forms. I think they're talking about p-adic numbers, bunch of stuff like that. So it's more like introductory material, and I think they're posting it on YouTube. So I'll probably follow along with some of those videos. And then as I understand it, they're planning for next year to host the conference they were going to host this year.
Okay.
Yeah. So it's the topic is modular forms beyond GL2. So Langland's type stuff, I guess. Which I think you might be able to justify taking the time to going next year, right? It's tangentially related, right? Representations, algebraic geometry.
Yeah, I mean, yeah, it's related to my more so my undergrad project, but yeah,
Right.
yeah, no, I think that's, I would justify going. It'd be fun. Mm-hmm.
So one of the last questions I like to ask here is, where do you stand on like the Platonism, formalism debates? Do you think math is, there's an ideal triangle out there? Do you think that mathematical concepts exist, or is it just like some sort of formal accident of language?
Oh, yeah, it's a hard question. Um, I don't know. I feel like I'm somewhere in the middle, but I definitely like go back and forth depending on the day, I think. Um, I don't know. It's too nice, you know, it's everything. It has to exist. Not like it works. Everything works how it should be. So I feel like it exists. And it like models like the real world roughly well, right? Kind of, sort of, sometimes. Like the universe and stuff, maybe. I think I'm definitely more on like the exist side, but sometimes I like to pretend that to think that it's just nonsense, fun nonsense.
Right.
Where are you on the stance of things?
I'm pretty firmly in the nonsense camp. I'm pretty I think that it's basically just a language, and that like, you know, we specifically, you know, we observe the physical world around us, and we specifically designed a language to mimic the world around us. So then, you know, when other things in that language continue to mimic the world around us, in some sense, I don't think it's you know, as perhaps surprising as Wigner would argue, you know, in his famous article, The Unreasonable Effectiveness of Mathematics. But so I was having some recent debates about this with people online, and I do think I need to read more of the literature of people that have come before me, you know, making my argument and counter arguments to that. I do want to dive in deeper, but yeah, I don't, you know, I think math corresponds to reality pretty well in many ways, but like, there's also places where it doesn't, right? There's right now, you know, we've got like all these infinities in quantum field theory. There isn't a, you know, our understanding of gravity and quantum mechanics don't play well together. And there's also like innumerable mathematical structures we can conceive of that don't have any bearing to reality.
That's true.
Yeah. So I would say I'm pretty firmly in that camp, but yeah, I mean, I think most mathematicians at least have some days that they wonder and they consider, well, am I wrong though? Like, some of this is kind of spooky, so yeah.
Yeah, it's a hard question. Yeah, I'm definitely on the fence, I think. Depends on the day. Sometimes it's just fun to do it for the sake of doing it. Well, I guess that's why I do it, but
right.
It's cool when definitely it's cool when you see like applications and stuff.
Right.
Cool. And it gives you really good intuition for things, which can be helpful and stuff. So
yeah. Although it's funny, I find sometimes like, yeah, definitely real world applications of things are they're great to like sink your teeth into and to like, yeah, get that real feeling. And it also helps because, you know, sometimes you'll be doing some like abstract nonsense and you're like, wait, why am I doing this? Like, what? I'm just playing some weird game, which I mean, I don't particularly mind most of the time. But for me, sometimes application means application to other abstract fields of math.
Yeah.
For myself personally, I'm like, I don't necessarily need it like a real world application, but I think need, like, I can't just dive into total abstraction. I like to think that I can, but I think sometimes I need to be like, okay, well, how is this thing gonna like help me solve this,
Mm-hmm.
you know, some other abstraction I already care about for whatever reason.
Yeah. That makes sense. I feel like we do that a lot, you know, when you take these like courses and stuff in grad school. It's like, why do I care about this? Oh, it's because it's related to this other abstract field.
Right. And you're like, yeah.
So like if you have really attached to that other field, then it's like you're Gucci, but you know, at some point you just, you know, down the rabbit hole. But
yeah.
So
I guess actually I thought of another thing just now related to the question about what else you would be doing, because you talked about thinking about not doing mathematics, which I also think about that constantly. Like, what if I didn't finish my PhD? What if, you know, I can't find a job after my PhD? Like, should I be preparing, you know, should brush up on my coding or crypto skills to try and get a job if that doesn't pan out? So it sounds like you've thought a little bit about that. Do you have any idea? Like, are you working on some coding in your free time in case that happens, or have you put any thought into like what part of industry you might transition if you decide to do that?
Not really, to be honest. Like I definitely am set on like, you know, I definitely want to go down and like attempt like the professor instructor route and like go do the postdocs. I'm definitely like setting my ways there. I've kind of lately not been sure. I've always been kind of set on like I want to do the professor routes and like do research and stuff, but every now and then I lean and I'm like maybe I'll do like just the teaching route would be really fun. So I'm not really sure that in that regard, but in the regard of like getting out of academia, I think, yeah, I definitely am not doing anything like to prepare myself. I think I'm trying to just put all my energy into to get the most out of this experience.
Right.
And it's like, cause I definitely want to like try for that route, but I think as math students, we're pretty like well like set up by the end of it. Even like out of your undergrad, like you develop a lot of like although like the math you learn might not be like applicable to like whatever industry job you get, I think you develop a lot of like useful skills and like, you know, problem solving skills and stuff like that. So I think like we're pretty like well set up, I guess, in that regard. So I'm trying not to like worry too much about it. But but yeah, I think like coding would be cool. I want to kind of learn coding. I've done a little bit, as I mentioned before. I'm definitely not a good coder at all. I'm like my algorithms are not efficient. They take like days and stuff to run. But I think that would be fun. I honestly haven't looked into like what kind of jobs are really out there though, like industry wise. I've heard that you can like go, of course you can kind of do like more like financy type number crunching things.
Right.
I've heard that there's positions that are kind of like you're doing like hard, like pure math research, but it's like in industry somehow. I don't understand, but I've heard about that. But yeah, I don't know. I should probably start looking into it, but
okay. So I guess I misunderstood a bit when you were talking about other avenues. You were talking more about just like teaching focused instead of research focused. Then.
I think like right now that's like what I would be between.
Right.
But I was more so speaking in like another world, you know, if I could.
Right.
Yeah, but yeah.
Yeah, I do find. I mean, obviously, I love the research aspect. I wouldn't be spending like every day doing research and you know, bothering to apply for my PhD if I didn't, you know, love the research part of it. But I really get a lot out of teaching in like, it's almost like in a selfish way, which I think is fine because it's helping other people. But like, I just really thrive teaching mathematics. Like, you know, I'm TAing number theory this semester, and I don't know, I just feel great when I'm done one of the tutorial sessions. It sucks it's not in person, but it's just, or I think I told you about the prison math project that yeah, so I haven't gotten my first letter back from this person, but like, I'm so excited. I can't wait to hear from this person. Like, yeah. So.
Yeah, I get that. I definitely get that. And it's not selfish. No, I think it's good. Teaching is very rewarding. And like sometimes research is hard. It's like, you know, it's a different kind of rewarding, I think, right?
Right.
Most of the time in research, you're just banging your head against the wall, right? So it's
Yeah.
like, I don't know, it's great, especially when you kind of like when you can tell that they really like it finally clicked for them, and like it's just, yeah, it's a fun environment to be in. I definitely like get what you mean, like when you finish like a tutorial and you have like that rush of like,
yeah,
and yeah, I get that. It's fun. Yeah, it's fun. I think that's like one of my favorite parts about, I mean, oh yeah, about like being a graduate student, you get lots of like opportunities like that. TAing. I don't like marking. But like it's fun to like interact and like host tutorials, and like I guess as a graduate student you eventually get like an opportunity to like teach a course or something. Last term I taught a kind of like a intro to proofs kind of course, but it was like an advanced, and like that was a lot of fun. I got to like, the instructor who ran the course gave me a lot of freedom, I guess, to kind of interact with the students, which is great. We have like Piazza, you know, you go online and you kind of prompt students a lot, and like other online like that. We also did like oral exams, which might have been like terrifying for the students, but I mean, they all did very well, and it was fun. It was like not the most like classical oral exam, which I think was great. We like, lots of the questions were like very like, I don't know how to put it, but like they just made you think, like compare this to this, and like stuff like that, rather than just the classical like compute this, you know, integral or something.
Right.
That was a lot of fun to kind of like keep prompting the students along and like kind of getting them to like, you know, the right direction, or like some of them came up with like great responses that I've never even thought of. So it was fun to like hear what they said. So that was a really good experience. It was a lot of fun.
Yeah, I think there's also that that really good learning aspect from teaching. You know, students, you know, coming up with a solution that you wouldn't necessarily have thought of. Also just solidifying your own knowledge. I mean, you know, probably at this point, and you've got an intro to proofs course content as down as you're ever going to have it. But it does, you know, when you're evaluating someone else's proof when they're learning for the first time, right? And you're sort of, you know, maybe they have a correct proof mostly, but, you know, there's little details that are like, this will make it slicker, a bit nicer, you know, just grammatically proper. And I think it is also worthwhile to, you know, give yourself that reflection on what makes a good proof.
Yeah, definitely.
Okay, well, that's I guess we've been at it for a while, so maybe we'll cut the interview off here. So yeah, thanks for coming on and chatting about math with me.
Yeah, thanks. It was fun. Yeah, it's great.
And hopefully we'll be at some conferences together before too long.
Yeah, hopefully.